All right, we got a ton of cool stuff here about the Artemis II mission. If you're into space exploration like I am, you're going to love this. We'll go behind the scenes at Kennedy Space Center to see all the work happening right now to get this mission ready.
Yeah, it's really incredible. It gives you a look at what it takes to prep a huge rocket, to send people to the moon.
It's like a backstage pass to something historic, right? But first, maybe just a quick recap. What are the Artemis missions all about?
Well, it's NASA's plan to get back to the moon. And not just visit, but stay there long term. It's about pushing the limits of science and technology. And that spirit of exploration, you know.
It's a new chapter for humanity, and Artemis II is a big deal.
Oh, absolutely. This is the first time we're sending people with Artemis. Remember, Artemis is uncrewed, so this is a huge step.
Okay, so picture this. The mobile launcher, the thing that carries the rocket, it's back in the vehicle assembly building after Artemis I. What happens next?
Time for a checkup. They inspect and fix up the whole mobile launcher. They use these high-tech scans to make sure it's all aligned, and they check every single system so carefully.
Yeah, there's this thing they mention, umbilical refurbishment. Sounds kind of sci-fi. What is that exactly?
Think of umbilicals as the lifelines of the rocket. They connect to it on the launch pad and provide, well, everything. Power, communication, fluids, even ways for the astronauts to escape.
Wow. I didn't realize they were so important, so they get checked after each mission, right?
Yeah, they got to be in perfect shape for Artemis II. No room for error when it comes to people's lives.
Makes those checks seem even more important. Every bolt, every wire has to be flawless.
Exactly, and speaking of flawless, what about those boosters? Those giant white things on the sides of the rocket?
Oh yeah, I can't miss them. What's it like to stand next to one of those?
It's pretty awe-inspiring, I gotta say. Each one's taller than the Statue of Liberty, 177 feet tall. And get this, they're not one solid piece. They're made of segments, kind of like a giant Lego set.
I remember watching a documentary about the Saturn V. I got chills just seeing those rockets. So how do they even build something that massive?
It's a carefully planned operation, that's for sure. First, the segments are brought from this special storage place, the rotation, processing, and surge facility. They're inspected there, prepped, kept in perfect condition.
So like a high-tech garage for rocket parts.
Exactly. Then they go to the vehicle assembly building to be stacked. They use these huge cranes to lift each segment into place.
So many acronyms. We need a whole deep dive just for those. But seriously, how do they get them perfectly aligned? It's so tall, there's got to be room for error, right?
You're right. Even a small mistake could be bad. But they use these laser guidance systems and very precise measurements, so each segment is lined up perfectly.
So it's not just brute strength, it's precision, too. It's fascinating how they combine technology and human skill.
And that's true for the whole Artemis program. We're sending humans into space, so everything has to be perfect.
It really emphasizes the importance of safety. It's not just building a rocket, it's building confidence.
Exactly. That care is everywhere in Artemis, even in the training those astronauts are going through.
That's true. It's not just about the machine. But let's stick with those boosters for a bit. You mentioned they have multiple segments. How does that work?
Well, each segment is like a giant metal cylinder, and it's filled with solid propellant.
So like a giant solid firework.
Kind of. You're on the right track.
Okay, these segments are packed with this powerful stuff, and it gives the rocket that initial push off the ground. Incredible.
Yeah.
But before we talk about the propellant, what happens back at that rotation, processing, and surge facility? What do they do to those segments before stacking them?
Ah, that's where things get really interesting. Let's head back there and take a look. So we're back at the RPSF, the rotation, processing, and surge facility. It's like a spa for rocket boosters.
Spa. I'm picturing cucumbers and face masks.
Right.
What do they actually do to prep these things?
Well, no cucumbers, but they are treated pretty well. Each segment gets these intense inspections. They use X-rays, ultrasonic testing, all that, looking for any tiny imperfections, cracks, anything that could cause a problem.
It's like finding a needle in a haystack, isn't it? How do they even spot those flaws in something so big?
Oh, they've got some serious tech for that. Robotic scanners that can see flaws as small as a hair. And if they find something, they have experts who can fix it. Or even replace a whole section if they need to.
Wow, that's amazing precision. Okay, so they're getting the royal treatment.
They are. And that's not all. After the checks, they get cleaned and prepped. Then they install important parts like the igniter and the nozzle.
So it's not just an empty tube. There's all this stuff inside.
Exactly. And each part is installed and tested perfectly. They even have these super clean rooms where they work. No contamination allowed.
It's like something out of a sci-fi movie. All these technicians in their suits, working on these huge machines.
It's pretty impressive, for sure. And remember, these segments have to handle extreme conditions. During launch, the temperatures, the pressure, everything's intense, so every part has to be perfect.
And then they're ready for stacking, right? Over at the vehicle assembly building.
That's right. And here's where it gets interesting. Remember those laser guidance systems we talked
It's
about?
the ones that keep everything aligned.
Exactly. Those lasers create a virtual line for the whole booster. So as each segment is lifted into place by the cranes, the lasers guide the technicians, making sure it's positioned perfectly.
It's like a giant game of Tetris, but with a rocket that goes to the moon.
Haha, I like that. And it's not just aligning, they got to connect them too, using huge bolts and special tools. And after each segment is bolted in, they check everything again, make sure it's tight and secure.
Wow, it's so complex, there's so many steps. It really makes you appreciate how much work goes into a launch.
It is, and it's not just about the technical stuff, it's the people too. Thousands of people work on this, engineers, technicians, everyone. It's what humans can do when we work together.
It's inspiring to think about. But let's talk about the astronauts now. What kind of training do they go through for a mission like this? I bet it's more than just learning to fly the spacecraft.
You're right, astronaut training is intense. It's demanding, physically and mentally. They have to be ready for anything, from the routine stuff to emergencies.
So what's a typical day like for them?
Well, imagine being strapped into a centrifuge. It spins you around at crazy speeds to simulate the G-forces during launch.
Yo, I'd be dizzy. But I bet the view must be amazing.
Oh, it is. Astronauts talk about the overview effect. Seeing Earth from space, it changes your perspective. You realize how fragile our planet is, how connected we all are.
It sounds profound. Back to the training, it's not just physical, right?
Definitely not. Astronauts need to be mentally tough, too. They're trained to handle being in a confined space, dealing with high-stress situations, being away from home for a long time.
It's a whole other level of preparation.
Yeah, they do these simulations that test their decision-making, how well they work as a team, how they handle surprises, and of course, they study everything about the moon. The spacecraft systems, the experiments they'll be doing.
They're like astronaut, scientist, explorer hybrids. It's incredible how much goes on at the same time.
And it's not just here at Kennedy Space Center. This is a global effort. People from all over the world are involved.
A true testament to collaboration. Okay, but now I want to talk about the actual journey. What will it be like for those astronauts to travel to the moon?
Ah, that's the big question. Let's try to imagine what they'll experience.
Okay, so we've covered all the prep work, the training, and the global teamwork behind Artemis II. But now let's put ourselves in those astronaut shoes. What's it actually going to feel like to be on that rocket going to the moon?
Well, first, imagine those solid rocket boosters firing up. You'd feel this incredible surge of power as the rocket shoots upward, pushing you back into your seat, like way harder than Earth's gravity.
Wow, I bet. We see the launch videos, but actually feeling it must be insane. And then you break through the atmosphere.
Yeah, and as you climb higher, you'd start to see Earth curve. Imagine looking at the window and seeing that thin blue line of atmosphere, and then just the blackness of space beyond it.
I saw a picture an astronaut took of Earth. It looked so tiny, fragile, just floating in this vast darkness. It really makes you think, huh?
It does. Seeing our planet like that changes you.
I can only imagine. But what about the more practical stuff on the trip? What will the astronauts be doing? Is it all work, or is there time to, enjoy the view?
It's both, for sure. They'll be busy with experiments, keeping an eye on systems, talking to mission control. But there will be time to just look out the window and take it all in.
What would they see during those moments?
As they get closer to the moon, imagine it getting bigger and bigger in the window, from this distant object to a whole landscape. Craters, mountains, these huge plains.
Wow, like going from a map to actually being there. Do they orbit the moon on this mission?
Yeah, Artemis II is going to orbit the moon several times, so they can gather data, test the spacecraft in lunar orbit, kind of like retracing those Apollo missions.
It's amazing that we're going back to the moon after all this time.
Yeah.
And then coming home, do they just turn around and fly back?
Not that simple. Leaving the moon's gravity, aiming for Earth, it takes these very specific maneuvers, engine burns. It's like a precise dance. You can't mess it up.
And I bet coming back into Earth's atmosphere is wild, too.
Oh, yeah. Another fiery reentry. The spacecraft heats up from the friction. It's intense, but also spectacular, like a shooting star.
Talk about a grand finale. So we've talked about all these amazing aspects of Artemis II. What's the one thing you want our listener to remember from this deep dive?
For me, it's the sheer scale of what humans can do. Artemis II shows us how far we've come in science and technology. It's proof that we can do incredible things when we work together.
That's a great point. And to our listener, I want you to think about this. Imagine being in that rocket, feeling those engines rumble, knowing so many people worked to get you there. What would it feel like to be on that historic journey to the moon? A journey that pushes our limits and reminds us of what's possible.
If you really want to grasp how big this is, look up some pictures or videos of those boosters being built, seeing those massive parts being put together. It'll give you a new appreciation for this incredible mission.
Thanks for joining us on this deep dive into Artemis II. Until next time, keep looking up.